use the forward rate model to calculate the price, right? So in this video, I'm going to share with you guys the forward rate model. So let's draw a timeline first. Time starting at 0 and all the way up to a certain time. For example, this t equals to m, and this t means time, of course, m plus n. And imagine there are two investors, investor A and investor B. Investor A bought one zero coupon bond at time 0, and that bond have a maturity of m plus n, which means at this time the bond will mature, and the bond will have a price. We call that P, price of m plus n. So m plus n means that is the time period of that mature of the maturity of the bonds. And then what about B? Say B also got into a contract, and they're not going to buy the bond right now, but they use a forward contract to purchase, right? So they bought a forward contract. Here at time 0, and that forward contract is about what will happen at time m. So essentially, is that B enters into a contract to purchase a certain bond, but that transaction will happen at time m. So during the time 0 to time m, B just holding the forward contract to buy a certain bond at time m at a certain price. And that contract was about, of course, a zero coupon bond. But that zero coupon bond starting at time m all the way to time m plus n, and in that way the zero coupon bond have a maturity of n rather than m plus n, because it's starting at time m, not starting at time 0. So of course you're going to use price to represent that bond. So the investor B cost a certain price to buy that bond. So we use that forward contract F as a forward, starting at M, ending at N, and we use that forward contract. We calculate the present value of that forward contract. So we kind of discount that back to now at time 0. Okay? And then you can calculate, because we got an equation here. Once you got an equation, you can use the equation to calculate certain things. Because these two investments, even though B seems a little bit complex, but the results should be the same. The two investments should have the exact same price, because if you buy the bond right now and hold that to the maturity, which is m plus n, you are going to receive the face value of that bond, because it's a zero coupon bond. Remember, it's a zero coupon bond. There's no compensation. There is no coupon during the holding period of the bond. So the only cash flow that you're going to receive is at the time m plus n, right? That is the scenario of investor A. But what about investor B? Investor B, even though it's pretty complex, they enter into a forward contract to buy a bond that will mature in n years. But the bond holding start at time m, and during all this 0 to m period, they're just holding a forward contract. They're not actually buying that bond. But at time t equals to m plus n, B also got that bond payout, because at that time the bond is a zero coupon bond. They will just pay the face value of that bond. Okay, so essentially the investor A and B are doing the same thing if nothing happens. So we got an equation. So if you look at the price right now the investor A paid, which is P m plus n, and the price that I discount back to now using the discounts formula to calculate that forward contract, these two should be the same. So let's rearrange that, shall we? Because we got the equation P m plus n equals to present value of the forward contract m n, we can get the formula, and because the present value also can be written as the discount factor. Okay, so the PV, say m, which is just discount that back to now, using the m as the terms of a discount period. You can use the d as the discount factor of m. Okay, so this is called discount factor. Discount factor essentially just the 1 plus a certain rate and certain period, for example m, and just discount that back to now, this discount factor. Okay, we just use the multiplication rather than division, because we don't like division, whether in computer science or in finance. So we can arrange this m plus n equals to the discount factor m, of course, and of course this is just a f. Let me erase that a little bit. Multiply f m n. Alright, so far so good. And you can divide both sides of this formula, and let me give you guys a little bit more space here. Let me write it here. So you use the price of m plus n, you divide it by discount factor m equals to f, which is the forward price of m and n. Essentially, this formula is the forward pricing model. So essentially, if you want to calculate the forward price starting at time m and ending at time n, so this period of forward contract starting here, you can use the price of the whole period right now. If you just buy right now and hold the whole period, and divide it by discount factor of this period, and you can get this forward. price. So thus the name forward pricing model. Okay?